Hello, can you hear me? Hello, sir, can you hear me? Rajendra sir?
Abhimanyu, I can hear you.
All right, can you see my screen, sir?
Yes, yes,
Okay,
able to see.
okay, sir, thank you.
Okay, thank you.
So let's do a quick recap of the concepts that we studied yesterday. So we'll look at a program first, a class program that should cover everything. Let's look at, yeah, perfect. So we declare a class. Shapes is a class name. Inside shapes, we declared a constructor. A constructor has no return type, but the name of the constructor is same as the class name, right? Constructor, by default, Java puts a default constructor with no arguments if you don't declare one, and assigns default values for all the variables in the class. So for string, the default value was null. This is very important. For integer, the default value was 0, and for boolean, the default value was false. All right. Now, as we go on, we saw we use the dot operator to call the methods that have been declared inside the class. What do we use? We use the default method to what do we use? We use the dot method to use all the methods defined in a class. All right. So we can we can have multiple constructors with multiple types like shapes, string, name, in size. So now because there's ambiguity in the name, string name and string name. So method has an argument with the same name, whereas as same as the string. So I need to write this dot name is equal to name, and this dot size is equal to size. So what does this dot do? This replaces it with the object, and we get the same variable of this particular instance of the shapes class, right? We get this, and we can have this constructor. Another important thing is, so I can have another constructor with 3 arguments: string, name, int size, boolean is closed, right? And depending on what I use, now can I use the default constructor here? Can I use the default constructor here? Will it give me an error or will it run? Let me just increase the font. Sorry. So how do we compile the program? Shapes dot Java. What does it say? New shapes with no argument. So what happened here? Now, because we have declared the constructors that takes arguments, and we have not declared any constructor with zero arguments, so we cannot use that constructor now. Make sense? We cannot use the default constructor now. So what do? We at least need to pass one argument. So now if I compile it, that error should go away. Now run it. Name is null, default value. Name is null because I did not pass anything. This gets executed. So name and is closed get the default values, and the sides gets the value 4. The name is null, side is false. So what if I pass square in this? Now what will happen? It will go and it will execute this constructor. What will happen? Is closed will get a an extra. Now name and sides will get a value, and is closed will set to default value. Right, this is what we covered yesterday under classes. Now let's continue. Just give me a second. All right, so let's start with today's concept, static keyword. So what is a static keyword and why do we need it? So static keyword is used when a member variable of a class has to be shared between all the instances of the class. So what is an instance of the class? The instance of the class is the variable that we create, right? Instance of the class is the variables and the methods, that object that we create, and the object has the variables and the methods. So all the static variables and methods belong to the class and not to any instance of the class. Is it clear? So static keyword is used when member variables of a class has to be shared between all instances of the class, and the static variable and methods, they belong to the class but not to any instance, right? So let's continue. We'll look at an example and it will be more clear then. So what happens? So when a class is loaded by the JVM, all the static methods and variables are made available for use to the user, right? So there is no need of creating an instance of the class if we wish to use the static variable or methods, right? And you have to explicitly define a variable or a method as static, right? You have to write the static keyword to make it static. By default, all the variables and the classes are methods are non-static. So let's look at an example. So let's write an example, actually that would be better. So public class static demo, right? So let's have a variable as a number, right? So what did we learn? When a class is loaded by the virtual machine, all the static variables and methods are available for use. So we don't need to create an object for that class. We can directly use it. We have been doing it. We have been doing it when we have been doing it throughout the program. When we did not learn about object creation, all our variables and methods were static. Do you remember? You are never creating a memory. So let's create a static int, and let's create a static boolean mm, attendance, right? And let's make it roll number, right? Now what do? I have my public static void main. See, even the main method is static, so that it can be called without creating any it can be called without creating any object of the class static demo, because we have to start the execution somewhere, and this is where we start the execution of the program. So that we can, so the JVM can call this main method without creating the object of this class. That is why main method is always static. So I can simply say, I can assign default values to it. I can simply say system.out.println roll number is roll number. Today's attendance is attendance, right? Right. Now let's have a static method as well. Set roll number, int roll number. What do I say? Roll number is equal to number. Now what do? I call the method set roll number, and I again call system dot out dot print ln updated roll number is roll number, right? Now how do I save it? This should be capital S. Always name your classes with a capital letter. Starting of the first very first character of your class name should be capital. Or Java. Now how do I run it? Where is my class? Static demo dot Java. Now how do I run it? Java C static demo dot Java. So it says okay. So roll number cannot be okay. So it takes an argument. I did not pass the new roll number. Let's say my new roll number is 200. What is the other error? Roll number cannot find the symbol roll number. I've made a spelling mistake. See, Java always gives you meaningful error messages, and it's very easy to compile your code, understand the errors. So initially, the default value for roll number was 110, right? And attendance was false. Now the updated roll number is 200. Now let's add a non-static variable as well, which is string name. What is this? This is a non-static variable. Now what happens if I try to .out.println name is, now what will happen is it will say a non-static variable name cannot be referenced from a static context. It means that this variable has still not been loaded into the memory. Why? Because we have not created an object for this class. So what does it say? What happens is when JVM starts, it automatically loads all the static variables and methods, right? But but the non-static variables and methods are only loaded when we create an object of that class. Is it clear? Non-static variables are only loaded when we create an object of that class. So now what do I need to do? I need to create an object. How do I create an object of the class? By default, Java will insert a default constructor. I simply need to say, what do I need to say? Static demo object is equal to new static demo. It's not a good name. Let's say instance. And how do I use the dot operator? Instance dot name. Now what will be the value for this? It will be the default value. Now when I say static, it will give it as null. Name is null. So let's do another thing. Now let's have a non-static method. Now instead of printing it directly, I say get roll number. Right? What will get roll number return? It will come here and execute this method and it will return the roll number. Now will this compile or will it give an error? Now this is a non-static method because we have not used the static keyword, and by default everything is non-static, right? So this is a non-static method now because we have not used any static keyword here. So will this program compile or will it give an error? And if it will give an error, why? What will be the error? So it will say we cannot reference a static context from a non-static method. This is a non-static method, right? So all the static content where is being used, right? It should always be inside a static method, right? It should always be inside a static method. Why? Because when JVM start, it automatically loads the static variables and methods, right? Oh, sorry. The return type is int, not void. Now it will give me the updated roll number is 200. Why? Because we are setting the roll number here, right? Now Let's look at another interesting thing, right? So let's look at another interesting thing, and let's do something. So um, let's remove this, right? Now let's create an object, right? So let's create an object of the class static demo instance is equal to new static demo. We create an instance of the object. Now let's set instance dot name is equal to Neha. Instance dot name is equal to Neha, right? I can directly access the method 111, right? And attendance is also a static variable is equal to true, right? Now now what if I want to display this variable, right? I want to display everything. So how do I do it? System dot out dot print ln. Let's just do it. I have to use the variable to access the instance. For Neha, I use a colon and I say attendance, and I simply say roll number. Now what will this do? First it will go here and it will create an instance of this class, meaning it will allocate memory for the non-static type variables and methods. So what will this do? This will create a create an instance of the class and allocate memory for non-static variables and methods of this class, right? But even before this happens, what does JVM do? As soon as the program is loaded, as soon as the program is loaded by the JVM, it creates memory for all the static variables and methods of every class that we have. Every class that we have. Is it clear? Is it clear? As soon as the program is loaded by the JVM, we have memory for these two and these two. They are loaded into the memory, but the variable name is not. When is name loaded into memory? What is memory loaded into name? When we create an object. So what is the basic difference between static and non-static variables? Static variables are loaded as soon as the program is loaded by the JVM, and static variables are available across all the classes. Static variables are available across all the classes. Is it clear? Are there any doubts? Are there any doubts? Please clarify your doubts. Please ask your doubts. Okay, go through this one, read it. I'll wait for a couple of minutes. If there are any doubts, please ask. I'll wait for 2 minutes. I'll pause here for 2 minutes. Okay, let's continue. So we have another example for a static keyword here. So what are we doing in this class? Static demo, static int a 100, int b, and static. We have a static method to access the static variable, right? We have a static method to access the static variable, right? So we'll look at this part later. Just ignore it for now. So static and non-static. What is the major difference between static and non-static variables? So static variables, we can access static variables without creating any instance of the class, like we just saw. We can access the static variables by without creating any instance of the class. They are already available whenever the class is loaded. That is, whenever the code is loaded. Again, we can also use them in any of our non-static methods. We cannot use non-static methods and variables without creating an instance of the class that they are bound to, right? We cannot use the non-static variables. Is it clear? So, non-static variables are initialized by the constructor, right? When we create an object using the new operator. Is this clear? These are a very important from point of interview. People generally tend to ask these questions. So please be very thorough with them and think about them for a moment. Let's go over them again. So what happens? Static variables are loaded. Static variables and methods are loaded when your program is loaded into the JVM, and they are available across throughout the program. Through all the classes they are available and the value is same. But non-static variables can only be accessed only when create a object of that class. Only after we have created an object by calling the constructor with the new operator. Alright, this is very important. Is this concept clear? Static and non-static? People tend to stay confused with this topic for a long time. Please ask if you have any doubts. This is a very important topic. Ask your coordinators to write it in the chat box if you're not comfortable. Do you want me to go over this again? Alright, let's continue then. This is how it works. So, this is how your complete program execution works. So, first step is the class is loaded by the Java virtual machine. Class is loaded by the Java virtual machine. What is JVM? I hope all of you remember what is JVM. JVM is the Java virtual machine where all our Java programs are executed. Now static variables and methods are loaded and initialized as soon as the class is loaded. So static variables and methods are available already. And only after the constructor is called, the non-static variables are made available. Right? Only after the constructor is called, then the non-static variables can be used. Right? So we cannot use the non-static variables in the static methods. Is it clear? Because they have no memory. Is it clear? They have no memory, right? Is this topic clear? Is this flow clear? Please read it again. Again stressing, this is a very important interview topic. They ask questions from it and lot of people make mistakes in it. Again pausing for 30 seconds. Please go through this slide again. See the flow. It should be crystal clear in your head. Difference between static and non-static, right? You will get a lot of interview questions. Please look at this. Okay, let's continue. So the next topic is method overloading. What is method overloading? Now, in the previous examples, we saw we can have multiple constructors with different number of that take different number of arguments. We saw we had multiple constructors that take different number of arguments, right? So let's look at the program again. So here we had three constructors. And what was the difference between the constructors? The name was same. Shapes, shapes, shapes. What was different? This was different. This was different. So what happens? Same thing applies to the methods as well. We can have multiple methods with the same name, but their signature. What is the signature? The arguments and the return type. The arguments and the return type should be different. Is it clear? The arguments and the return type should be different. Return type does not really make any difference, right? We'll look at that example. If we have two methods with the same type of arguments, the return types are different. Java cannot differentiate between them. Is it okay? Now let's look at an example of this program, method overloading. So let's have a new class, public class example, right? Now public class method overload. Now let's have different types of variables. The first variable is, okay, let's do it like this. Let's go inside public static void main string args, right? Let's have two integer variables. Let's have two byte variables, and let's have two short variables. Now all of these variables, what is the common thing? All of them store numbers. What is the range for byte? Minus 127 to 128 to 127. What is the range for short? 0 to 255. So let's start. Now let's first declare the methods. What are the methods that we have? Public void add, right? Public void add int a comma int b, right? What will it return? It will return int. And what do we show? We say int c is equal to a plus b and return the answer. Add these two numbers and return the answer. And just to be so that we know what was executed, we simply write a statement for clarity. Add method with arguments of type int was executed, right? Now let's have another method, public byte add. What does it do? I hope you guys remember the method signatures. Okay, we need to differentiate even though they are same, but still, right? System dot out dot println add method with arguments of type byte was executed. Byte c is equal to a plus b. Return c. Public short add int e comma int f. System dot out dot println add method with arguments of type we already have done int, right? Learn it short, not int, of type short was executed, right? Short c is equal to e plus f. Return c. Now there are a couple of interesting concepts to look at. Now c was declared inside these parentheses. The scope of C, that is, the memory allocated for C, is only valid within these parentheses. So we can declare another variable C and that will be used here because the memory is valid. The memory of the C that we declared first is not valid outside those parentheses. Got it? Second thing, what does the first method do? What does this method do? It takes two arguments of type integer and returns a value of type integer, right? Returns the value of type integer. Now let's create an object of this class, new method overload, right? Default constructor which Java will automatically include. Using default constructor which Java automatically adds to the class. And what is the exception for this? Default constructor is not added only if we declare any constructor. So if we declare any constructor, then default constructor will not be added. Otherwise Java will automatically add a default constructor. Somebody's mic is on. Can you put it on mute, please?
It's 3 o'clock.
Okay, let's continue. So let's call system.out.println. Let's add integer variables. Right? Let's assign values to these variables first. A is equal to 1, B is equal to 2, C is equal to 3, D is equal to 4, E is equal to 5, and F is equal to 6. Right? Add int variables. I simply call add. What do I do? I pass A comma B. I pass A comma B. Add byte variables. Add C comma D. And I write system.out.println add short variables. Add E comma F. Is it okay? I say add E comma F. Now what happens? First, should we see the output? Okay, let's see the output first and then we'll understand what is happening. Did not save the class. Save the class. Method overload dot java. Java C method overload dot java. Oh, spelling mistakes. This should not be here. Okay, so we need to use the variable int dot add. So what did it say? A non-static method cannot be referenced from a static method. So if you have to refer this because this is a non-static method. No memory has been allocated. So what do we need to do? We need to use the class instance. Okay. Oh, okay. So what is it saying? We cannot add. It's saying if we add, we are converting it into int, and there might be a. Let's update this. We'll look at this typecasting a little in the next couple of next slides. For now, yes, let's do this. Right now, what happens? What is happening now? So what we did was we'll go through it, right? Java is automatically converting the result of an addition to integer, and this is called typecasting. I wanted to avoid this, but we'll look at it in a couple of slides today. For now, just go through the concepts of the overloading, right? So now what is happening is I have three different types of variables. I have three different types of variables. What are those? Integer, byte, and short, right? And I have methods defined in this class. What are those methods? Int add with arguments, int and int, add arguments with byte and byte, add arguments with short and short. So what happens now? There are two important concepts to understand. First, when we execute this statement, right? When we execute this statement, what will be the output? Now, this statement will be printed only when the semicolon is processed. So first Java will go and it will execute this method. It will go and execute this method. It will say add method with arguments of type int was executed. Why? He passed a and b. A and b were of type integer, right? A and b were of type integer. So Java goes and it pattern matches. It says, hey, listen, I have integer types now. So I have to add two integer numbers. So it adds them and it returns them, right? And then this statement will be executed. Added into variables and the output is 3. 2 plus 1 is 3. Next, what will happen? Add byte variables. We'll say instance.add cnd. See, it looks like we're calling the same method, but internally this method will be executed. Why? cnd are of type byte. So Java will go here and execute this. See, add method with argument of type byte was executed, right? So Java goes and first executes this method and then prints this. Is it clear? Similarly for short, Java comes here, executes the short methods, it executes this line and then it adds them, returns it, and then this is executed, right? So whenever an overloaded method is called, the Java compiler, it automatically selects the appropriate method by type and order, right? By type and order. So let's look at this. Let's look at having a couple of other examples as well. Public void display. I have two methods. First method is int a and short b. It takes two arguments of type display int comma short, right? Let's have another method with the same name, but let's reverse the types in it, right? Now I have two methods with the same name, right? I have two methods with the same name display, but the argument ordering is different. So we have two methods with the same name and number, same name, number, and type of arguments, but the ordering of the arguments is different. So Java will automatically match them. So I simply say display a comma c, and if I say display c comma a, right? C is of type byte. I need short. Okay. So let's say E. Let's say E. Now what will happen? Sorry, I have to use the. So now see, when I passed int A is of type integer and E is of type short. Similarly, E is of type short and A is of type int. So when this was executed first time, what did it say? Display int short was executed. So it went in, it called this method. It matched A int A with A, E short with short. Similarly, next time I pass this, it matched it with this, right? So the number of arguments, the ordering of arguments is also important. Okay, now the next question, and this is an important interview question. Please look at it carefully. Now, can I have a method of type int display int A short B? Can I have this method? Return the constant value 0. Now, can I have this method? Now, this part is entirely same. This part is entirely same, right? The only difference is this return type. The only difference is this return type, right? So can I have a variable with same number of arguments but the only difference in the return type? Is it possible? Is it correct? Or will this give a compile time error? It will give an error. Why? It will say, hey, I have already declared a method here. Now you cannot declare the method with the same name. Why? Java does not know that which method is calling, if it is expecting a return type or not. It simply matches the name and the arguments. So we cannot have a method with the same name and same two methods with the same name and same type and order of arguments, but with different return types. It is not valid. Why? Because at the time of calling, Java does not know what is the return value being expected. Is it clear? Is it clear? Please look at these concepts and try and understand them. We'll pause here for a couple of minutes. If you have any doubts, please ask me. Please ask your doubts. Okay then. I'll still wait for the day and you ask me a doubt. We'll continue. So overload methods declarations with identical signature will cause compilation error even if the return types are different. That's what we saw now, right? That's what we saw now. Two methods, the same declaration type, but even if they have different return types, they'll call given compilation error, right? And why is that? Because the return type is not necessarily known at the method call time. So we saw the example. Now, how does it work? So a signature of the method is its name and the argument list. The signature of the method is its name and the argument list. So Java, it distinguishes the overloaded methods with their signatures. It looks at the name, number and type and order of its parameter. If Java only looked at the method names, then the previous code would have given us errors, right? So internally, the JVM, it uses longer method names that include the original method name. So what does it do? It rewrites the names. So it uses the original name, it adds the types of each parameter and the exact order of each parameter when it rewrites the class file, right? And that is how we have unique. So let's say for an example, this method name, what will happen? What will compiler do? It will rename to add int, right? So whenever we call add with two integer arguments, it will look for this method. Similarly, this will be called add byte. These are not the exact names. It might use something else. I'm just giving you an example. So how does the compiler differentiate between these two methods? So one of them will be named as display int short, right? And the other will be named as display short int, right? So whenever we call display with the argument of int and short, it calls display int short. Got it? If you understand how it works, it is easier to remember. Got it? And overloaded methods, very important, cannot be distinguished by return type. Okay, so let's start with the inheritance concept now. This is again a very important topic from interview point of view, right? So we'll look at it. So what is inheritance and why do we need it? So before we dive into Java inheritance, let's talk about where do we see inheritance in the real world. So whenever a child is born, right, a lot of us say it looks like look like he looks like his mother or he looks like his father. Why do we say that? Because a lot of the features of the father or the mother or both are passed on to the child, right? They are passed on to the child. The child has all the features or some of the features of the parents, right? So similarly in Java, we have the concept of inheritance, right? So a class, right? Think of there are two classes, subclass and the superclass. Subclass and superclass. So superclass plays the role of the father and subclass plays the role of the child, right? What are the features of superclass? The variables and methods, right? And what are the features of the subclass? They also have variables and methods, and it also has the variables and methods of its superclass, right? So the subclass inherits all data attributes of its superclass. So subclass inherits all data attributes of its superclass. First point. The subclass inherits all methods of its superclass. Got it? It narrates all methods of its superclass, and it also narrates all association of its superclass, right? It also narrates all association of its superclass. Okay. So subclass can then add new functionality, that is, it can add new methods or use superclasses methods or override what the superclass had written. We'll look at all the examples in a couple of seconds, right? First, let's take an example. So here, person is a superclass. Person is a superclass, and the subclass is of type employee. Employee is a person, right? Employee is a person, right? So we say employee is a type of person, and all the properties, that is all the variables of the class person, also define an employee. Employee will also have a string and date of birth, right? But employee will additionally have employee ID, salary, and start date. Okay. Next is what happens when an object is creating using new. The system must allocate enough memory to hold all instance variables, right? That is, if I create an object of the type employee, right, then I should, the Java machine also allocates memory for the superclass. Also includes memory for the superclass. Is it okay? Is it clear? Java also allocates memory for the superclass. So employee is a kind of person. So relationship is what? Is a kind of person, and it inherits all the attributes, methods, and associations of the person. Is it clear? Whenever we say that that employee is a subclass of person, what does it mean? It has all the access to all the variables and methods declared in its superclass, which is person. So how is inheritance declared in Java? Right? How is inheritance? So inheritance is declared, right, using the extends keyword. It is defined using the extends keyword, and by default every class in Java extends a base class called object, right? Every class in Java extends the base class called object. Even if you don't extend anything, you by default extend the object class. So let's see an example. So how do we do it? We have a superclass called, this is our superclass person, and we have a subclass called employee, which extends person, which extends person. Got it? And how do we create the constructor? The same way, employee is equal to new employee. So there is a rule in Java which is different than other languages. In Java, every class can only have one superclass. Every class can only have one superclass. Is it okay? Every class can only have one superclass. Cannot have more than one superclass, right? And this is what how it looks like. So let's say we have a class here, just super class. A small class extends from it, another class can extend from it, another class can extend from it. There's no limitation on the number of subclasses that we can have, right? What happens? This is a superclass. This becomes a subclass for this superclass. Then this becomes a superclass for this particular class, and this becomes a subclass for this superclass, and so on. It continues, right? So classes which are lower in the hierarchy, that is classes which are here, they are more specific and well defined and concrete, right? They have almost the complete functionality, right? There's no limit to the number of subclasses we can have. There's no limit to the depth of the class tree also, similarly. Okay. So object class, like I told you earlier, every class by default extends, if it does not extend any other class, it extends the object class, right? So either every class directly extends the object class, which Java ensures by default, or it extends some other class which extends the object class. So object class is the root node of the tree. So this tree, this is basically our object class, and every class extends from this class, right? And the object class is defined in which package? Java dot language package. So we have seen we use constructor to initialize the instance variables. When a subclass is created, its constructor is also called, right? It is the responsibility of the subclass constructor to invoke the appropriate superclass constructor, right? To initialize the variables. So superclass constructor can be called using the super keyword. So like in the constructor, when we create an object, we call the new variable and do this. So for calling the superclass constructor, that is the parent class constructor, we simply use super keyword. We use super keyword. So to call the superclass constructor, we use the super keyword, right? What does the super keyword do? It basically goes and calls the constructor of the parent class, the super class, right? So if I do not call the super constructor, what will happen? The JVM will try to call the default constructor. What is the default constructor? A constructor with no arguments of the super class. By default, try and call the default constructor of the super class. Is it clear? Are there any doubts? Let's pause here for a couple of minutes. Think. Please ask your doubts. Okay, let's continue. So let's look at an example for constructed. So we have a class called bank account here. And what are the properties of a bank account? A bank account can have owner's name, account number, and balance. Right? It can have an account number and balance. So now we have what? We have an bank account constructor which takes an account number and name, right? And now we have another class called draft. We can go to a bank and make a draft. That is a draft account. Now it has a draft limit. It has a draft limit. What does it do? See, this is a constructor for this class. Now this class calls the super constructor for this class. It sets the account number and name, right? It sets the account number and name, and then it sets the limit to some value. Is it clear? So subclass narrates all methods of a superclass. Okay, but sometimes the functionality implemented in the why do we have this all, right? So subclass will define a certain set number of variables and the methods, right? So I know I need all this functionality, but I need some other functionality as well, right? So what do? I say I'll extend this class, right? I'll use its current functionality plus I'll write some other functionality and I'll use it, right? So why don't we modify the superclass directly? Because that superclass might maybe is a possibility it is being used by somebody else, all right? It or maybe that functionality is limit enough for some other task, right? So what do? I simply extend that class, create a new class and say I'll do that in my new class. I'll do that in my new class. Is it clear? Any doubts? Is the motivation clear behind classes? So a class defines certain set of variables and methods and is defined for a particular functionality. It's defined for a particular functionality. So what do I say? I simply say, hey, listen, I know this class is there. So, so what will I do? I'll simply keep that class as it is and I will add another functionality by extending and creating a new class, right? So we'll look at this examples in a while. So let's look at the examples for this and then method overriding. Chalo, let's start coding some examples now. So first we have to look at the inheritance example. Then we'll see how we can call the constructor of the superclass. Finally, we'll go and we'll see what is method overriding, right? Let's define a class. Public class person, right? What are the properties of a person? Person can have a name, person can have a age, right? A person can have a name and an age. So let's have a constructor for this class. What does it take? String, name and age. How do I refer to this? This dot name, this dot age, right? Right? So I have this functionality. So let's add a method also. Public void display. I have a method public void display. So what does it do? It simply displays the name. and also the age. That's it. I save it with person dot Java and I replace it. It says there's already a class name person. I replace it. Now I have another class called public class employee. Now employee is a type of person, so I say it extends person, right? Extends, right? What are the properties? Int salary, right? String position, right? So I have a constructor for this class now. Public employee int position, sorry, int salary and string position, right? Now, now let's say I do not care about the other things. I say I do not care about the other things. I'll create a static method and I'll simply construct the variables. Constructor for this class employee emp is equal to new employee. What do I need to pass? The name salary. Salary is 10,000 and the name. What is the position? Manager, right? Manager. There are classes already, right? Now what do? We simply say, because I have created the constructor, I can access the non-static members. So I say system dot out dot println, right? System dot out dot println. What do I say? Name of the employee is. But there is no name here. There is no name here. So where is the name coming from? The super class. The super class. Employee dot name. Let's see what happens. What will it say? A person cannot be applied to the given types. Oh, sorry. Java C start dot Java. Now we have to compile all the classes, right? Required string int. Okay. What is it saying? Constructor person in class person. Okay. Sorry. So now if we look at the person class, what do we have? We have a string name and age, right? But we did not call the constructor of that class. So what do we need to do? We need to call super. What does super do? It calls the constructor. What is the argument that is accepting? Name and age. So let's give a default name for now. Rakesh and 23. Now let's recompile it. It passes, right? Now I simply say Java employee. The name of the employee is Rakesh. So even though there is no name in this class, is there a variable called name in this class? No, right? Where is it? It's in the person class. We are still able to access it. Similarly, we can say age of the employee is age, right? Age of the employee is emp dot age. Age is 23. Salary of the employee is emp dot salary, right? And similarly, right? Similarly, position is p dot position. Is it clear? Position is right. Now, what is next? What is next? Now, what do? I have created this employee. Now, let's add another constructor which takes more number of arguments. So, it takes string name, int age, int salary, and string position, right? We call super with name and age, and we say this dot salary is equal to salary, and this dot position is equal to position, right? What are we doing? We are assigning the default name. No name was supplied. Now we say employee emp is equal to new employee Abhimanyu, 28. The type is manager, right? Type is manager. Now we saw we had a function called display in the person class, right? We had a function called display in the function class. So I called, okay, we already have emp. So we say employee or emp1. emp1 dot display, right? We call emp1 dot display. Let's compile. Let's run. What does it do? Name is Abhimanyu and age is 28, right? But now I saw that display is printing only the name and age in this class, right? Because only name and age are here. But what do I want? I want everything, right? I want salary and position also. So I say I'll write my own method display. I'll write my own method display. What will I do? I'll put system.out.println. Name is this dot name. Age is, what does this operator do? The instance of the class that is calling it is replaced by this. Salary is this dot salary. Position is, it okay? Now what will happen? Now I have a display here and I have a display here, right? Which one will be executed? The new one. Now it will print everything. Oliver is printing. Name is, this is, now it is printing everything. This is called method overriding. Method overriding. Earlier I was displaying, earlier what I was doing? I was displaying only the name and age due to my superclass method. But now I am displaying everything, What am I doing? I am displaying everything, right? How? By overriding the display method in my super class, right? So what can I do? I can define new variables. I can define new methods in my subclass. I can still use the methods that are defined in the superclass or the variables that are defined in the superclass, right? I can override the method. I can have the method with the same name and ordering and type as in my superclass to change the functionality of what was being done by my superclass. So I want to extend the functionality. So I simply override override the method in the superclass. This is called method overriding. So what is method overriding? I override the functionality that is implemented in the superclass. What do I do? I override the functionality that is implemented in the superclass, right? The same function, the same name, if I declare it in the subclass, which will be called the function which has been defined in the subclass, right? If this function is not here, if I do not declare this function, what will happen? The function from the superclass will be executed. So the constructor, okay, method overriding. So a subclass inherits all the methods of its superclass. That we saw. It had access to the display method, right? Sometimes, like you saw, the display method was only displaying only the age and name, only displaying the age and name. So what did we decide? Okay, name and age are not enough. What will we do? We'll override it and display salary and position also. We'll display salary and position also, right? The example that we have already covered. Okay, so let's do a quick recap of inheritance and references. So inheritance defines a kind of relationship, right? What does inheritance define? A kind of relationship. Like we saw, person, employee is a kind of person. Employee is a kind of person, right? So relationship can substitute object references. So uh, we can also, instead of saying, what it is trying to say is, so I declared it as employee. So I could have also said person, and this would have been correct. So this will not give any, okay, but I cannot access the following members then. Wait. I can do this, right? The name, everything is still there, but if I declare as person, what I cannot do? What can I not do? Hello, sorry. Yeah. So if I declare as class person, I have to. I can directly say with this reference, but I cannot directly call it with an object like this, right? So I can also replace the employee part with person, right? Because employee is a kind of person only. So I can also declare the variable with the superclass reference. With the superclass reference. Are there any doubts? Are there any doubts, questions? Any questions, any doubts? Please ask. I'll wait for a couple of minutes. Please turn your mics on and ask questions or ask your coordinators to write in the chat box.
Okay, in that case, let's stop here. You can go on to your class labs and practice. We'll stop the meeting here.